longing for Daisy. Yeah, not dream out across the water. Tired deep on suicide water.
Have a nice weekend.
Can I use that trash can?
Yeah.
My stuff like now, but I don't want to get counted off. Like right now in the basket. Okay.
I already graded your book signing. She turned it into a basket.
Okay, so now you just need the certificate.
The certificate, you didn't show me it yesterday.
Okay.
Heard that? Huh? Turn in your circuit. Yeah.
Oh. What is this, boys?
I think it was a long road to get there, but
How's that book going? See you making some progress.
oh yeah, I used to be right here,
Nah,
and now I'm right there.
20 more pages.
I'm on page like 250 right now.
We're not turning. Are you gonna use that for the York app? Oh, you're not applying for it. You're not even applying.
Well, I applied, I'm just not applying for the
Okay.
I don't want to take that. Gosh, it's so.
You did? Yeah. I like that line.
Stacy broke the car.
I know it's all been like this. Every single class in this hallway.
It's
on
just straight up
Mondays,
cold.
And it's just I'm all day.
I forgot to take my.
John, finish your book something?
Yeah, I did actually. Yeah, last time. So many. Yeah, man.
I like
It'll be like.
Oh, you're cutting it close. Like,
It's not as cold.
you underestimate.
Oh, my papers.
Yeah.
Wait.
I don't underestimate.
someone put the wall. Someone put the wall.
Did you guys know Richmond Sandpaper? Yeah.
We had a little moment.
It definitely was very natural. Wow. I can't believe I walked in on that natural motion.
No, I didn't slip, but.
Have you played? Have you played like
last,
talking?
like,
Am I talking or making my hands? Yeah, me too. I always just I can be your belt. Oh. You're really on your now. You're feeling really. Or you're just feisty. I think we should bring back some flavors.
Yeah.
Oh wait, should we turn in our? Yep. Or no, Mark, you first.
I don't know.
Oh no, let's
Yes.
Ooh, good eye.
read your book something.
Captain,
actually involved what you're doing today, or
Yes. Yes. Did you talk to her? Yeah. She goes. I saw her in the hallway and she started laughing. I started laughing. And then it was like,
she wasn't mad at all?
No, no. She's like, so y'all got written up, huh? And I'm like, yeah. It's kind of a story. It's kind of all John's fault. No. But on the paper it said that me got my phone taken away, not you. So we didn't tell her it was actually me.
Yeah. No, that's fine.
And then she was just confused. She was like, I don't understand why you went back 3 or 4 times.
Well, you got like twice. But like, I don't know why she got mad about that. Because it was creepy. She was
At least she could have said, hey, stop disrespecting her.
yeah, like she didn't even tell us why. Yeah.
Yeah, she just took our name. Other than that, she said no bad.
Y'all need to get out of the way if you turn stuff in.
Alvin.
Okay, if I did not get your circuit yesterday, this is your last chance for full points. And also, if you did not turn in the long book assignment in the Google Classroom, again, you should give me what you've got, but this is your last chance for full points on it. So. Give everybody a second to get settled in. Right here. Alright, so today we're going to spend just a few minutes on assignment 23 and 24, where we'll talk about the last big piece of Unit 2 class. Unit 2 for us, and that is on chain rule. So I have mentioned that a couple times to you already, but before I even show you what chain rule is and talk about it, it's first important for you to realize that chain rule is not a new type of differentiation. It's an additional step. So you're still going to be using power rule maybe, or product rule maybe, or quotient rule maybe, and then after that sometimes you do chain rule. So it's just adding one extra step to that. So assignment 23, I've got some notes for us to quickly kind of talk about it, and then 24 we'll practice some of that, and then on 25 will be on your own piece of paper, and I've got some Khan Academies for you to try out. 3 of the 5 Khan Academies are on chain rule. 2 of the others are on some other stuff we talked about. Okay, so chain rule is going to be necessary anytime you have a composite function. That's anytime you have a function that's plugged into another function. Composite function, anytime a function is plugged into another function. So, the first thing is I'm going to try to convince you that the power rule is needed and try to compare and contrast it to some that you should be able to do. Now, if I asked you to have done this question, take the derivative of this yesterday, I would suspect a lot of you, maybe most of you, would just do the power rule. You'd bring the power down and then lower the power by 1. That's not how that works, unfortunately. To show you what the correct answer is, you could simplify this with algebra, specifically exponent rules, and then you could take the power rule. So 6x to the 5th. Now, of course, if it was something that simple and written that way, I would just simplify it and use the power rule. But sometimes we can't simplify it like this, so we have to understand why this is not working, and it's supposed to be that. So, same question, y equals x to the 3rd all being squared. So, when I look at this, there is an inside piece. There's something inside that's x cubed, and x cubed is being plugged into the big outer piece, which I'll call u squared. So in place of u squared, they're plugging in x cubed, and that's where they're coming up with that. So to help you see the steps, this is how you need to phrase it in your head every time you work this. These 3 steps. You're going to take the derivative of the outer part. So the derivative of u squared, you're still using your normal derivative rules, would be 2u to the first, but with the inner function plugged in. So we're not going to say 2u, we're going to say 2x cubed. So I did the power rule, brought the power down, lowered the power by 1, I'll even put the 1 there, and I left the inside function plugged into it. Okay, you also have to think about the derivative of the inner function. So if the inner function is x cubed, 3x squared would be the derivative of the inner part. And then to get the correct answer, you can take the derivative of the outside part with the inside part plugged in times the derivative of the inside part, and you end up with 6x to the 5th. So again, I know it's a real basic example, but I'm just trying to show you we knew that was going to be correct. But this 3-step process is kind of how you want to phrase it in your head. You want to think about what's inner and outer. In fact, one of the 5 Khan Academies I'll ask you to do the second half of the class today, just ask you to think about what's the inner part and what's the outer part. You're going to take the derivative of the big outer part with the inner part plugged in. You're going to take the derivative of the inner part, and when you multiply those 2 together, that gets you the correct derivative. So to show you one that you don't know, and you don't have an option to rewrite, y equals e to the 4x. Again, there's not much that you could do with this. I mean, I guess if you were creative enough, no, not even if you're creative. So when I look at this, I would say the outside part is e to the u. It's e to something, where the inner part, u, is 4x. 4x is being plugged into e to the u. So mentally, I'm thinking about what's the derivative of the outer part. Well, the derivative of e to something is going to be e to something. Now, I've been saying the derivative of e to the x is e to the x, and that's true. But now I'm going to start to say it this way. The derivative of e to something is e to something. But notice, I need to make sure I plug in this inner part. So don't say u, leave the inner part plugged in there. Don't change the inner part. Then you need to take the derivative of the inner part, which is 4. And when you take the derivative of the outer with the inner plugged in times the inner part, that process is the chain rule. Honestly, the multiplying by 4 is what is considered the chain rule, that additional step. Multiply by the derivative of the inside part. Now, on the next page, this is just kind of typed up. Same things that I said, same function that we did first, same second section, so I just thought that maybe typing that up and having words to match up to that would make sense. But this guy right here, this is the same thing, but this is written in math symbols. So sometimes this is helpful. Well, I don't know. Some students like to learn it this way. I don't learn it this way, but this way is pretty handy, specifically when you're trying to do chain rule with tables. And notice, again, it looks complicated, but it's saying the same thing. F is the outer function, g is the inner function. They're taking the derivative of the outer function with the inner function plugged into it times the derivative of the inner function. So it's the same 3 steps that I was doing on the other page. Derivative of the outer function with the inner function plugged in times the derivative of the inner function. This times the derivative of the inner function is what we have to train our brains to do. Because if you don't think about, and I probably should have said this at the start of class, but chain rule is probably the single most important thing we do first semester. It's equivalent to unit circle and pre-calculus. Like pretty much everything we do the rest of the semester, chain rule is something we have to consider. So we have to make sure that we think about it every single time. Okay, so a couple quick examples, and then we'll do a few more on the next page. But when I look at this, I see I've got something to the 7th power. So just look at all of this as like one big thing. If it's something to the 7th power, bring the power down and lower the power by 1. So that part is the derivative of the outer function with the inner function plugged in. Notice I didn't bother doing anything with the inner function yet. And then times, and for all these examples we do on the board today, I'll put the chain rule step in a different color here. But you've got to times the derivative of the inside stuff. So it's not that you've been doing derivatives incorrectly, it's that every derivative question you've seen up to this point has been rigged, where the derivative of the inside was always 1, and multiplying by 1 doesn't change anything. But the derivative of this inside would be 3 minus 10x. All of that makes up the derivative. So the first part still just power rule. It just looks more complicated because it's got a mess of stuff under there. I'm telling you to train your brain to then come back and multiply by the derivative of the inside piece. Okay, number 7, same idea. I'm going to rewrite this first though. If this stuff is squared and cube rooted, that's like it's like to the 2/3. Okay, so first part, no different, just looks more complicated. First part still just power rule. Bring down the 2/3 and lower the power by 1. Again, I'm not interested in simplifying right now. Obviously, we would normally move this to the denominator. Times the derivative of the inside. So I'm still just doing power rule on the great big picture and power rule on the inside picture, but the part in red, remembering to come back and multiply by the derivative of the inside, is what we consider chain rule. So something like question 8, what's the derivative of sine something? Okay, cosine something. We're not just saying x anymore, we're saying something, so it's more open. What's the inside part of this function? 2x is the inside part. So the derivative of the inside would be 2. You've got to multiply by 2. What's happening is you're multiplying your x value by 2, so it's moving along the horizontal axis twice as fast, which is making the derivative be twice as much. The rate's increasing twice as fast. Okay, and then quite a few on your circuit yesterday started taking this shortcut, which is good because I don't want you to have to derive this. But the derivative of tangent something was what? Not secant. Okay, so secant squared something, and then come back and multiply by the derivative of the inside part. Come back and multiply by 2x plus 0. And that's your answer. So again, it's not different, it's just an additional step. After you do the derivative stuff you've already learned, you have to multiply by the derivative of the inside unless it's 1, because multiplying by 1 doesn't change anything. Okay, last thing I want to say about this handout is if you guys looked up like a calculus formula sheet, or if you looked in like the front or back cover of our textbook that we use, it's got all the stuff that you will eventually have to memorize, all the derivatives, all the integration second semester. But just so you know, because you should kind of now be able to do this, it's not going to say this on the formula sheet, because this is only true for x. What they're going to say is u, so this is a u, and then what else are they going to have with this derivative? Times what? U prime. U prime. It's not really u to the first, u prime. You got to take the derivative of this inside part if it's needed. So that's the reason it's written that way, because they're speaking generally whatever's here goes here times the derivative of whatever's there. So they those formula sheets, always write it this way to make it applicable to chain rule. But it's the same one that we memorize. Okay, our second handout this morning is us practicing some of these. So let me continue on, and then we can start branching out, and I'll let you practice a few of these on your own before we go over them together. Okay, so question 1, there's the function, here's the derivative. Now, my last class said that this has come up. I guess it doesn't really matter here, but I do need to make sure that you guys are aware of this. Sometimes when we talk about a function, we might say y, and his derivative would be y prime. Sometimes we talk about a function, it would be f of x, so his derivative is f prime. I need you to also know, though, that the derivative of y can also be written like this, dy over dx. Have y'all seen that already? You have? Okay. So this means derivative of the function. This means derivative of the function. Just two different mathematicians. One mathematician likes to use this notation. One mathematician uses this notation. It turns out that this one's kind of convenient to write just because it's so easy. But there are a few calculus things we do this year that we like to write it this way. But just so you know, those are the exact same thing. I don't want you to ever get confused with that. Okay, so I'm looking at this question number 1 as just a big picture. I've got something to the 4th power. So I'm going to start off, I'm going to take the power rule, bring the 4 down, and lower the power by 1. So that's the derivative of the outside with the inside still plugged in. Notice I didn't do anything to the inside yet. Now come back and multiply by the derivative of the inside. 12x plus 7. All of that's the derivative. Okay, number 2 looks like power rule again. We've got, we can bring the negative 2 down. We can lower the power by 1. Again, I'm not bothering simplifying right now. And then I need to come back and multiply by the derivative of the inside piece, which would be 8t minus 3. Again, the part in red is the chain rule step. That's the step that you need to try to remember. Okay, 3, to go from y to y prime, I could bring this 1/3 down, lower the power by 1, still same old power rule, but I need to come back and multiply by what? -8. The derivative of the inside would be -8. Okay, the derivative of cosecant something is going to be what?
Negative cosecant x cotangent.
Okay, so you said x. Let's just keep it the same though. If it's 7w, 7w, 7w. Good. You have that memorized, or you got it in front of you?
In front of me.
Oh. I was almost proud. Okay. All right, and then that's on the test. That's on your AP exam. That's one of your answer choices, 100%. But what do I still need to do to this before it's right? So multiply it by 7. So just obviously you can take the derivative of 7w. It's just a matter of will you remember to do that? Because you have to do it every single time. Every single time. If you don't consider chain rule, automatically you're at a 50-50 chance of getting the question right. Okay, I think question 6 is one of the harder ones to piece together, but I want to give you a shot because I want you to see if you can kind of navigate that. So try number 6. We'll go over, correct it. Then I'm going to take off a couple of these that you don't know how to do yet. And then I'll give you a few minutes to actually try the rest. Okay, so again, you need to first step back and try to think of the big picture here. This is 2 times sine of something. So the derivative is going to be 2 times the derivative of sine something, which is cosine something. The something just happens to be a big mess of stuff. Times the derivative of what was being plugged inside, the inner part of the 2 sine x, or 2 sine u, which was 3x plus tangent x. So you had to come back and multiply by the derivative of 3x plus the derivative of tangent secant squared. You got all that? Okay, that's great. If you got that already, then you're in good shape, because that's kind of hard to see. Again, I keep underlining the inner part to help y'all see that, but that's really what we're aiming for here. Okay, I would like you to try some of these other ones, but you don't know how to do question 9 yet. I haven't shown you how to take the derivative of an exponential function that doesn't have a base of e, so that's why you can't do that one yet. And you don't need to be able to do question 10 yet, because I've not shown you how to take the derivative of an inverse trig function. Right now we're still learning the regular trig functions. But I would like you to try the other ones, and I will try to be about 1 or 2 questions behind you. So go ahead and write down what you think you should do for 6, and then I'll discuss it in a minute, and then we'll keep going until we've got this practice done. Now, I think this is probably, this is where you hopefully are by the end of class, but one of your Khan Academy assignments is questions like these, but multiple choice. So. Here's my answer to number 6. So the derivative of tangent something is always going to be the secant something. The something stays the same. Don't try to take the derivative of the inside part right away. Then after you leave the inside function there, times it by the derivative of the inside, which was times 10. Of course, normally we put the 10 out front, but same difference. Okay, my number 7 is, again, I'm writing them and then pausing for a minute, so that way if you're checking once in a while, you know which ones you need to listen to. So number 7, the derivative of a constant is 0, so that's why the 5 just disappears. The derivative of e to something is still going to be e to something, just like e to the x is e to the x. E to the 4t plus 7t squared still needs an e to the 4t plus 7t squared, but you have to remember to come back and multiply by the derivative of what's being plugged into the e to something. And the derivative of 4t plus t to the 7th would be 4 plus 7t to the 6th. Yes?
Appreciate it. Thank you.
That's enough?
I think we're good. Yeah, my name is good. Thank you.
Got the next couple answers up there. Again, I'm just sharing the answers early. That way you know if you're still on the right track and should just keep going, or if you need to slow down a little bit. So my explanation to those couple, number 8, once again, the derivative of e to something is still going to be e to the something. Just make sure you come back and multiply by the derivative of that something. The derivative of 1 minus cosine x would be positive sine x. Number 11, the derivative of natural log of something gives you 1 over the something. Just like the derivative of natural log of x is 1 over x. If it's the derivative of natural log of some big mess of stuff, it's 1 over that big mess of stuff times the derivative of what's being plugged in. And the derivative of that stuff is negative 10y plus 3y squared. Pause here for a minute and make sure everybody catches up, because 13 is a very, very, very good question. Putting that exponent of 6 in a different spot changes how you should approach it. So I want to talk about that one. Okay, but with 12, once again, the derivative natural log of something is 1 over something. So I have 1 over that mess. And then I came back and read and multiplied by the derivative of that something. The derivative of sine is cosine. The derivative of cotangent is negative cosecant squared. So minus a negative made that a plus. Okay, number 13, the first part should be okay. I think that's the easier half of this, but this is 2 terms. You have to do 2 different derivatives. The derivative of sine something is cosine something. That's why I have this in black. Times, the derivative of this inside was not 1, so I had to come back and multiply by the derivative of x to the 6th here. But then this one, a lot of times calculus students struggle with this because you guys don't remember what this means with trig functions. Trig functions, we do the exponent slightly different. But this means you've got sine of z, the whole thing's being raised to the 6th power. It's just with trig functions, we like to put it here instead of here because if you don't have parentheses, like if we do it like this, then we don't know if you mean the z is being raised to the 6th power or sine of z is being raised to the 6th power. So that's why we do it like that. So I'll just use this space up here. So sine of z to the 6th power looks like this. So right here I just did power rule. I brought the 6 down, lowered the power by 1. That's regular old power rule. Then I came back and multiplied by the derivative of the inside. And the derivative of sine is where the cosine comes from. Yeah.
Did you put the 6z to the 5th in the front? Because it was internal, but you're like multiplying it?
It doesn't matter. The order of multiplication doesn't matter. So
you could like still write it on the end.
You could write it on this end, yes. So there was actually one, I won't make you get it out again because some of you actually gave it to me, but there was one question in your circuit yesterday that I think was like, bless you, sine squared, and it gave you a hint. It said rewrite this as sine times sine and then do product rule. Well, now that you guys have seen chain rule, you can see that this really means this. You could bring the power down, lower the power by 1, and then come back and multiply by the derivative of the inside. And to me, that's a little bit quicker than doing the product rule. I mean, same answer, but if you look at your circuit, you'll see that there was a question like that. Okay, and then let me give you just a second to try the last couple if you haven't yet. And once again, I'll put my answers up and verbally describe what I'm doing here. Okay, so for 14, again, this is 2 terms, so we just have to do 2 derivatives. Over here, I brought the power down 1/2, lowered the power by 1. Again, I'm just not worried about simplifying here. And then I had to come back and multiply by the derivative of the inside, which was 7w, so it's times 7. The second term, the derivative of e to something, is still e to something, but then you need to come back and multiply by the derivative of the something. And the derivative of negative w would be negative 1. You treat it just like negative x. W is just a different variable. W's instead of x's, z's instead of x's. All right, and then 15, this first part, you don't even need chain rule. Bring the power down, lower the power by 1, and that's because the inside is just z, and the derivative of z is 1. So I guess if you really want to multiply by 1, you can, but that's not going to change anything anyway. And the derivative of sine something is cosine something. Make sure you remember to come back and multiply by the derivative of that something. Derivative of z squared plus 6 is 2z. So it's not, chain rule doesn't really make things harder, except that it's one more step and you have to remember to do it. So is there anything that jumps out at you about any of these questions? Got the general idea? Okay. Then we need to practice some stuff, the majority of that being chain rule. So you will need some scratch paper. If you want to number your scratch work as 25 in case I need to see it, and so that you can have a place to put your notes. So 2 of them have nothing to do with chain rule. One is on the definition of a derivative. I have something in your notes about that, but I haven't made you practice it yet. One on estimated derivatives. And then the 3 on chain rule. I don't have a preference which order you do these things, so feel free to do whatever you think is going to be the easiest and work your way out. Okay, and I know you guys have this stuff in your notes, but here are a few tips that I would give you, or a few reminders that I think would be helpful. When you do the one on definition of a derivative, again, you could look in your notes, 2 ways to write that. We talked about trying to do process of elimination to figure out which one is which. So we did like 4 of those in your notes, and I told you I'd let you practice those at some point. I just haven't had time until today. The one that's talking about estimating derivatives, remember derivatives just means slope. So use the slope formula to estimate what the slope is, / estimate what the derivative is. And then the other 3 are on chain rule. One chain rule just wants you to identify the inner and outer parts, so I would probably do that first. It's meant to be kind of a build-up one. There's one where you need to do chain rule given a function, kind of like the last handout we just did. And there's one that asks you to do chain rule, and they give you a table. And if I was you, I would use this formula that we just talked about for those table questions. It's still chain rule, it's still the derivative of the outer, but the inner plugged in, times the derivative of the inner, but trying to formulate it and write your work out that way, I think will help that make sense. So I will leave these up, but honestly, if I was you, I'd probably just write them on the top of my scratch paper so that you can refer to them a little bit quicker. I can't leave this up the whole class anyway. And this is the rest of your class assignment / homework. Looks like second period. 14 people finished in class, so a little more than half the people were able to finish it with no homework. But this is only the second time we've done Khan Academies in here this year. I do quite a few of them first semester, not so much second semester. But remember, if you miss a question, It has that little link in the bottom right pop-up that says get help. Obviously, if you missed it for some reason, you should probably learn from your mistakes so that you don't just keep making that mistake. Of course, it makes the videos that it has very accessible. If those help you, then they're right there. And you're welcome to retry things as many times as you need to get 100 on them. So again, I like that because some of you only need to do a couple estimating derivative questions. And if you can do 4 in a row right, then you're done. But some of you probably need to do 20 or 30 of those before you really sink in what you're doing. So if you need that practice, then you will get that practice. And you don't have to do the busy work if you don't need lots of extra practice. So. Does anybody need me to come by and try to help out yet? Okay. These are the definition. So is it more the top form or the
I
bottom
tried
form?
it. Actually, like at the end of the and like
You need to be comparing it to the two forms you're supposed to memorize.
Yeah.
So is it more the top right or the
The
one
last
below?
one's really hard too. Maybe I'm just
Top right.
So in the very top right of that form is going to be the function, or the function with the value plugged in, which is what you've got. To the left of that is the function with x plus h plugged in, or a number plugged in for x. So if this is the function x plus h, I would say the function is probably square root of x. And for that question, that's enough to know the answer.
For this one,
Yeah, there's only one that says the function is square root of x.
I thought though it's
So that form is always with h equals 0. The other form tells you.
this one's the question.
That's correct. So think about this. If the function is square root of x, and that's a 3,
Okay.
what's the square root of 9?
You're basically taking the derivative of the top.
No.
Wait.
You're using this compared to the standard definition
Okay.
to extract that the original function was the square root of x, and you're finding the derivative at 3. Or I'm sorry, at 9. Because if the function is the square root of x, and there's a 3 there, they must have plugged a 9 into it.
So you're saying x is 3.
And the value they're trying to find the derivative of is 9.
And then because it's in this position, x plus h.
F of x plus h is this. So they're saying the function is x plus h. So the original function must have been the square root of x. That's how I know that that's enough to get the answer. That's supposed to be the function at that value. So if the function is the square root of x, and there's a 3 there, what must they be plugging in for x? 9, so that's the value right there. So that's all you can do is you've got to compare that to those two, and then try to distill some of the information enough to narrow it down to one choice. Now, -1 is the function with some number plugged into it.
Yeah, and then it'd be
What do you think the function is in this question? Okay, so it's got to be A or B. All right. Since it's the bottom form, what is A?
A can be 0 or negative. Just 0.
Just 0. Here's A. Here's A. This isn't A. That's f of A. So they're plugging in A into what they think the function is, and the cosine of 0 is 1. That's why they chose that.
Okay, thank you.
Kind of heavy though. It's not heavy?
No, it's really not.
No. You should just put like a whole counter and monitor in your body to carry that around. Again, you can do these 5 in any order, so if you retry one a couple times, feel free to take a break, do a different one, and just come back to it. Honestly, that might be the best anyway. Alright, anybody else need me to come over to help? Yeah, I almost did. It was nice when it comes in. You don't, no, it's fine, it's fine, you just do one or the other. If you're not sure if you did Google Classroom, I'd rather you just give me the hard copy. I just didn't want you to think you had to do both on your own. I don't know, aren't those both yours?
Yeah, but I thought I stapled them together, but it looks like I stapled them first.
I don't know. I didn't unstaple them. Or maybe you stapled them, but you kind of missed.
I think I missed.
Depending on the form, these answer choices. So it looks more like the standard definition in the top right or the alternate version below. Okay, I would agree. So the alternate version, the top left of his numerator is supposed to be the function. That's not the function. That's the function. That's square root of x. That's square root of 4 plus x. That's not the same thing. A or C, right? Okay, minus f of a. So f of a is the value you want the derivative of. F of a, right here. A is what? Okay. What is f of x? What happens when you put a and then f? Square root of what? Which is 2. There you Okay, so they're wanting you to figure out what the original function was and what what you're trying to find here. So that is going to be one of those two. You've got to decide if it's more like the standard definition of a derivative on the very top right, or the alternate version right below it. Okay? And the alternate version, once you memorize that, the top left of that fraction is supposed to be the function. So what's your function in this question? Okay? So how many equations have that as a function? Right, over. This one's math log x squared. Oh, so there's only two that have the right function. So we're already done 50-50. Okay, and then in the denominator, the bottom right of the denominator is supposed to be a, and this is supposed to be a, and then the top right is supposed to be f of x. So if you already figured out that f was natural log of x, and you know a is e, yeah, so you had to plug in that to get that. To get one.
Wait, how do you do the tables for the chain rule?
I would use that formula down there.
Yeah.
So if you want to know, oh no, you're not doing that one. You're doing estimating derivatives.
Oh.
So right here, if you want to know the derivative at 16, so you can use the slope formula between 15 and 16, and whatever that is a good guess for what the derivative is. Of course, any mistake that you make multiple times or anything that was not intuitive to you, you should put on your scratch paper so that it's easy to find in the future.
Oh, wait, no, I. Wait, what?
cosine to the negative.
Mm-hmm.
It would.
Because it's cosine x all to the 9th power.
So the outer function would be cosine.
No, if cosine is the outer function, then you'd be plugging stuff in the cosine. Cosine is the inner function because you're plugging it into something to the 9th power.
Okay.
Okay. Any questions? Anything I can help with? Okay, so this you're gonna have to memorize the derivative of natural log. It's gonna give you 1 over something. So in this case, it's gonna be 1 over x to the 4th, like that. But then because of chain rule, you gotta come back and multiply by the derivative of x to the 4th.
Which is 4x to the 3rd, right?
Right? Uh-huh. And then that looks good. Okay, but then when you simplify that, so if you write it as one big fraction, you have this times that.
Yep.
Okay, so this x to the 3rd can cancel out some of those, and then that's why they're getting 4 over x.
Oh, okay, okay. Thank you.
Mike, you got something I can help with? No. Deposit means like you've got a function that's being plugged into something else. To me, that looks like a function times a function. It doesn't look like there's a function being plugged into, so not a composite. That would not be one either. That looks like a function divided by a function. Because it looks like e to the x, but something's being plugged into it. Anything I can help with? Any help? Yes, we can. Every day. Here it is.
Oh, so I didn't
Oh, are you?
I think it was the same. I was like, that's fine.
But it's a way of saying we're going to take the derivative of that.
Oh, wait. Yeah, so I'm that's what I have. There's no I'm honestly don't hear this. Do you want to buy me? I'm gonna guess when you figure it out. Oh yeah, that's Starbucks. That's just my guess for the future. And then
And I need to know.
Bunch of my company are.
I need 4 shots.
yeah, I would keep doing like
Quadruple shot of what, espresso?
Yeah, I would just
I typically get caramel macchiato, ice, triple shot. I'm gonna get quadruple shot.
Start tweaking out.
Not looking good? What are you trying to do? You're trying to estimate the derivatives. What is derivative of? At negative. What is derivative? Okay, so we really want to know the slope at -9. So where's that going to be near in your table? Okay, so if you use the slope formula from negative 10 to negative 8,
You can do it.
whatever the slope is here, negative 9 is probably the same. If you know the slope between negative 10 and negative 8, you've got an estimate, but it's probably the slope of the function. You got more information.
Is that mathematically?
I'm not sure if it. Wait, I think it does.
What's negative 88 minus negative 85?
Negative
2 over 3.
It's a slope formula.
Yeah.
There we go. Clicking now.
Is your first one on that?
Going, boys.
It's my third one. Oh, okay. You got it. Oh. I just spent like 2 minutes. Bro, if I get this one, I'm gonna go. I would full of it. Full of it.
Oh, I don't know.
I don't know half an hour.
Why am I? Wait, you know what really confuses me? When people take PayPal and how like down to the why are you in pre-cal?
Yeah, what?
I didn't do that one. I don't know why. I don't like
I do not understand.
No.
I know.
It was the first one.
Maybe. And I don't know why. Maybe it's like actually. Because I know some colleges are like more into I'm not trying to take nothing home.
But it did. Yeah.
But actually, it's not really engineering.
Of course it's not.
All these answers are pretty more like.
I know. I just have to finish this one. You gotta go to like university.
So,
No, I
because they've all got
Oh
this,
yeah,
and
don't
they've
even
all got
play.
this, that's not-
Yeah, oh, this is
So, in the top right could be the function, so it could be
Bro, when I look at the
EDS,
doctor and see their colors,
or
I
it
didn't
might be
think I'm
EDS with a thousand plug-in.
There's like a Ford, like
Here
a
is supposed to be this
gorgeous like
function.
truck, a G-Wagon,
Right,
like.
so first, this is a function.
I don't understand.
They make that
But
big.
this part, it either needs to
He also does like
take E
kind
to
of the
the
guy.
x plus h, or E to the x plus h with a number for the inverse.
That was
They did that big.
okay.
Well, the problem with these is, so they want to find a derivative, so that's why they're plugging in each. But you're not gonna plug in an E here, this part, if you don't also plug in that E to that part. So, you're either gonna do both or neither.
I got one for that.
They plug in the E here, and then that should be E to the x, so they plug in. So that sounds good.
The exponents are just messing me up.
Yeah, those are just hard question types. I mean, it's not, you know, normal math where you can just do your steps.
You're going whenever x equals to 1.
Well, I guess you don't need help. Did you do AP Stat last year?
No, I did college algebra.
College algebra. I knew you did something different. How did you like finite?
It was
Very different though, isn't
economics, to be honest.
it? Yeah. Do you do like Venn diagrams or
Yeah, at the beginning,
statistics?
with probability, there's a lot of diagrams.
I can't ever remember the difference between combinations and permutations. Did y'all do those?
Yeah, I think permutations order matters and combinations.
I know, but until I force myself to do it 20 times, I can't. My brain doesn't remember.
For h of x. 2 for whenever x is 2.
You ever seen at Sonic where they say they have like 30 million different drink combinations?
I've not seen it.
Oh, okay. They used to advertise that a lot, and it's just that's all they're doing. They're doing
That's like nonsense.
yeah.
Yeah. It's beautiful.
Making the rounds.
Okay, y'all still have about 15 minutes. Nobody's asking for help right now, so if you know you need some help, please call me over. If you don't finish these in class, you're welcome to finish them up for homework, but I'm going to put in the grades at the start of next class, which would be Tuesday. So I guess you guys could come see me on Tuesday during advisory if you're really struggling. But.
Okay.
My sincerest apologies. Thank you.
Is it gonna make me start over if I go out?
Did y'all like not afford toys growing up? You learn to play with paper dolls?
Big stick and rock band.
Oh, because of nothing.
So do I have 13 more minutes.
Are you serious? He is quitting.
That's the option you have left. Drop it.
Thank you. Yeah,
That's what she says to everyone.
He's my second. Were there a lot of people there? Why are you so popular?
There's a function plugged into the
Yeah, I think that I need to, but it's
natural like
Riley, you know who's ridiculous?
So I think it's on the second floor. Okay, now we can see our
Anything we talked to. You know
That one,
what?
that one.
Oh, I mean, I got it. And I'm trying to see if they can check the cameras. Because, like, no, I don't know how much they eat. Actually, like,
Wait.
this person, like, they have cameras of the
In the middle.
All I gotta do is look for a light part that doesn't come in, like, anything just
Goes sideways and there's like a-
my blue.
Oh wait, I feel like I know.
I think that his office is like
It's
third
so
floor.
good.
Like,
No, that was Monday, but I didn't realize there were those cameras in that service.
Bro, my
I
dad
had to
would
get
do
like
it.
the late
My
night
dad would
stuff
sit there for
first.
12
I got
hours.
that dropped off and
Oh yeah, you know he was in Sky.
I think it's,
Oh,
then
yeah.
I talked to Zeke.
I think it's third floor and then like the basement is third floor.
Yeah, I'll ask like every single teacher to have an
Because I went with one of my friends to pick up her ID.
Yeah, I did.
All I, yeah, there's white paint all over the back, but kind of like, you know, like the way that I got hit on the sand. So like, I tried like a full roll, like a sedan, and they hit the wheel well, the back bumper, and somehow even got up onto the trunk.
Did you guys know that Corona?
Like, that's something that you gotta like hit my car and then keep going, you know? It's almost like wait, are you?
I've literally the last one. Well, I always been more
You're the one who totally stars.
Bro, that's awesome.
My worst like fear is getting in a car crash. I enjoy like I know
I hit a
like
truck.
I'm dead.
I did.
Like in my
I hit
car,
a
bro.
pole
Like
or
I'm
something
dead. Like calling wheels, bro. Like you like
Oh my God,
T-bones me. That's it.
I don't know. Like going 40 miles per hour. It's so like we have a rush so much.
It's just this
I know.
student line is like this is the second time I've been hitting that bar.
Really?
Yes. The first time was the first time I was in the car, and as I was driving the same way, he's so sweet. One of his dad, no shade. But I was fucking straight. The entire front of my car passed her, and she hit the back.
That's impressive.
And that was an estimate of 4K. And thank God she's at fault. Like I had right away.
This is not making on me. That's what I really don't like. Mine's like, oh, that's so dumb. But it's like, would I do that? I'm definitely
Oh, I'd be wrong. You don't mind?
Oh wait, you've got me.
Okay, no, I have no idea. Which one of those is the
No, don't think. I know it's I know it's the bottom, like the F of X minus F of A.
I really thought I was
So
going
the
to
top
finish
left is supposed to be F of X. So what's that?
How's that go?
I'm not even halfway done, I hear.
I'm looking at the top left of this fraction. Top left of this fraction is F of X.
You know,
And the
the
top
first
left
two
of your
things.
fraction. So your function is supposed to be X squared.
Oh yeah, that's
So there's only one choice that has X squared as your function.
Where's the H?
Oh, right here?
Yeah.
Okay.
The others are not X squared, so those can't be right. But you might still want to practice it if you're still not.
I don't get it.
Did somebody hit your car?
Somebody did this for you.
Yeah, Monday.
Good luck.
Yeah, I would have filed a police report in the parking lot, but I didn't know because they hit the back of my car and I faced the school, like I parked facing the school, and so I was on the interstate. My rear bumper started flying off.
Oh, it wasn't here at school.
No, it was at school, but I didn't realize that they hit
Oh, I
the
see.
back, and like I literally just hopped into the driver's side and like started driving, so I didn't realize until I was down the road.
Do you know this, the parallel parking on the west whatever over here? Hopefully this was meant to be all. But last year I saw some girl trying to parallel park in this spot. It was like a perfect fit. But she backed into the car behind her like 5 or 6 times. Like over and over. She just kept hitting it. And then one time she actually got in pretty good, but her back tire was on the curb. So she gets out and she tries to push her car back in. Yeah. And I don't know if she told the person behind her, because I mean they weren't in their car. But their car just kept shaking. And then she would pull all the way back out and start the parallel park completely over from scratch and just do it again.
I know my limits. I don't even try to parallel.
Oh, I would not.
You know, I
can
can't
do okay,
it.
but that was a perfect fit. Like I don't know what she was thinking.
It's very really bad.
Did we do this puzzle yesterday or the color puzzle?
We did the color one.
This is so weird.
Oh my gosh, they're upside down. They're upside down.
Is that the mistake?
Of course they're upside down.
Oh, it's the fake. The mouths are upside down. It's the mouth.
And the eyes.
Okay. I'm sorry. No, I'm bad at everything.
That's really
Yeah.
I was the
Are you sure? They look good to me. Okay. Okay, here's the picture flipped over.
Ugh.
Yeah, I was like in the morning.
Sarah texted me saying she found the Is it okay to ask John?
If you don't believe those are the same pictures, just turn your head upside down.
I feel like they would tell you if they weren't.
No, well, if I say like I'm going to a funeral, I don't think it's the same. But I also don't say that. Yeah, I've never shared that.
But it's just like in all that,
In the hallway,
and it's just like, and then you can't see the face. Yeah.